You are currently the only person in this conference.
Welcome back to the virtual classroom of Chembase School of Chemistry. Can you hear me? Sound clear? Right, so in the previous lesson, we completed the Unit 4 syllabus, and I'll be discussing a few the latest papers, 2020 Jan and paper 4 to begin in 2029. I hope all of you have got the copy of the paper and answered whatever possible. Let's start the discussion. This question is about 4 organic compounds, each with 5 carbon atoms but different functional groups. You have acid chloride, aldehyde, ketone, and an amide. Which of these, when mixed with water, produces a solution with the lowest pH? That means acidic solution. Lower pH means acidic solution. Amides are neutral. Ketones doesn't produce acids. Acid chloride, when you put water, what happens? It forms the carboxylic acid and it releases HCl as a byproduct. So as HCl is produced as a byproduct, it's acidic, so the pH is lowered. So answer is A. Which of these reacts with ethylamine to form N-substituted amide? It also has to be acid chloride. Acid chloride reacts with ethylamine to produce N-substituted amide. So answer still the same, A, the acid chloride. Which of these reacts with iodine? I'm just continuing one after the other. If you got your answer wrong, or if you need any further clarifications, please let me know. Which of these reacts with iodine and sodium hydroxide solution to produce a pale yellow precipitate? This is iodoform reaction. This is iodoform reaction. So any compound which contains methyl carbonate group or which produces methyl carbonate group upon oxidation. You can see there's a methyl carbonate group here. So this produces a yellow precipitate, right? Therefore, the answer is the third molecule, which is propane, not propane. This is ketone, which is 1, 2, 3, 4, 5. Pentane 2-one. Ketone. Which of these molecules can rotate the plane of plane polarized? It has to be a molecule which has a chiral carbon, a carbon which is attached to 4 different entities. You can see this C, this carbon is attached to 4 different entities. 1, 2, 3. This is the whole thing is one group. 2, 3, 4 different entities. So that's a chiral carbon that will rotate the plane on the plane polarized monochromatic light. A polymer is prepared by the reaction between hexane dioyl chloride and hexane 1,6-diamine. What type of polymerization occurs? This is acid chloride with diamine. It's a condensation polymer. It's a condensation polymer. In fact, this is nylon 6,6 polymer. That's the name of the polymer, nylon 6,6. After each question, I'm pausing for about 5 seconds so that if you have any questions, you can forward. The compound reacts with excess sodium hydroxide solution, what is the organic product formed in the reaction? Now, this is what happens here is that both of these carboxylic groups, carboxylic OH, the O will be replaced by Na. This OH, the hydrogen will be replaced by Na. That's all. Nothing happens to double bonds. Nothing happens to double bonds, right? So this just OH, the hydrogen of the OH group, replaced by a sodium. Which diagram shows the mechanism for the second order reaction between 1-bromoethane and potassium hydroxide in aqueous solution? Now, 1-bromoethane is a primary haloalkane. So primary haloalkanes undergo SN2 mechanism, which involves a transition state. And there is no carbocation in it. There's no carbocation. So this is wrong. Can you see there's carbocations formed? So those two are wrong. And this, let me check this, diagram 3. Yes, that seems to be correct. This seems to be correct. We'll check the other one. This is wrong because arrow should always start from electron rich and it will point to the electron poor. Electron rich to the electron poor. So diagram 3, correct, which is, see, always in the mechanism, arrow moves from the electron rich to the electron poor. If a bond is formed, if a bond is broken, arrow should start from the middle of the bond and should point to the atom where the bond is broken. Which of these reacts directly with ethanoic acid to form ethanoyl chloride? PCl5. This is a straightforward question. Any carboxylic acid will react with phosphorus pentachloride to form acid chlorides. Which of these changes has the largest increase in entropy of the system? Let's see. Largest increase of the entropy of the system. So the enthalpy change doesn't matter here. Solid to liquid, entropy increases, positive. Liquid to gas is more positive than solid to liquid because gases can get more disordered than the liquid. Entropy is lowest in the solid, right? Then comes the liquid. Then the gases will be the highest. So this is more positive than A. B is more positive. C is negative. Because a liquid and a gas giving aqueous. And graphite to diamond, both are solid, there's no change. So more positive, largest increase in system entropy is liquid to gas. Question 8. Equal amounts of W and X are mixed and allowed to reach equilibrium. Equal amounts. The value of the equilibrium constant Kc is given. At equilibrium, the mixture will contain. Now see, Kc is this. Y times Z over W X. Now the Kc is 4.85. It's a positive value, right? Which means your Y and Z will be greater than X, W and X. When the numerator is greater than the denominator, you get a not point value, you get a plus value, right? So let's see the answer. The mixture will contain at equilibrium almost all Y and Z. No, Y and Z will be a lot. What? Not more Y and Z, but all Y and Z won't be there because there will be a little bit of W and X as well. Almost up. This is wrong. W, X, and Y, Z, but there is less Y and Z. No, there is more Y and Z. This is correct. D. because there's more ions, the numerator is more than the denominator. Clear? Question 9. What does X represent on the diagram? This is gas to aqueous. This is the enthalpy of hydration, right? Hydration enthalpy. This is lattice. This is lattice enthalpy, and this is solid to aqueous is enthalpy of solution. This is enthalpy of hydration. Enthalpy of hydration. Let's see the answers. Sum of changes of hydration of the gaseous ions. Correct. Enthalpy change of formation, no. Solution, that is this one. Lattice energy is the other one. This is sum of the enthalpy. Sum of the enthalpy changes of hydration of gaseous ions. Enthalpy of hydration is defined as the enthalpy change when 1 mole of gaseous ions dissolves in excess solvent, resulting in infinitely diluted solution. How 20 cm cube of 0.05 mole per decimeter cube sulfuric and 20 cm cube of 0.1 mole per decimeter cube ethanoic acid aqueous alike? Both solution have same pH. Can't be, right? This is strong acid and weak acid. No need to do any calculation. It can't be, right? Can notice, but this concentration of ethanoic is twice, double the concentration of the sulfuric, and the volume is same. Volume is same. Concentration of this is double. Let's see. But anyway, pH can't be same because this is strong acid, the other one is weak acid. They have the same total concentration of the ions. Let's see that is possible. No, because the reason sulfuric will not dissociate this way. So 0.05 sulfuric will not dissociate this way. I think we had a detailed discussion. If that happens, then you're correct. This doesn't happen that way because there are 2 levels for dissociation for sulfuric. One is complete, second is partial. Right, so if you have 1 m sulfuric, it won't give 2 m sulfuric. It will be less than 2 m. Right, so that if that is not the case, B is correct answer, but B is wrong because 1 m sulfuric, I mean 1 mole of sulfuric doesn't give 2 moles of H+. If that happens, then it's correct. They have the same total concentration of negative ions. No, that's wrong because negative ion concentration here and there is not the same. Because this is 0.05 sulfate. 1 mole of sulfuric gives 1 mole of sulfate. Likewise, 1 mole of ethanoate gives 1 mole of ethanoic gives 1 mole of ethanoate. The concentration is different, so it won't be the same. This has to be the answer. We'll see. Require 20 cm cube of 0.1 sodium hydroxide for the complete reaction. Is right? Is that correct? 20 cm cube of 0.1 sodium hydroxide. Yes, that's correct. Because thing is this: if now see this, this is sulfuric acid, the ethanoic acid, 0.1, 0.1. Equal concentration require equal volume, right? But sulfuric is if you write sodium hydroxide and sulfuric and balance the equation, that'll be 2:1 ratio. The ratio will be 2:1, right? So because the ratio is 2:1, the amount of moles of sodium hydroxide should be twice. 0.1, 0.05 influences 0.1. So that is correct. Got it? which two solutions, both of concentration 0.1 mole per decimeter cube, have been used to produce this titration curve. Now this is, you can clearly see here, the end point is midway of the vertical inflection. It's 9. That means alkali. The strong alkali and weak acid. When the alkali is strong, the acid is weak, right? Weak alkali. So strong alkali, right? For example, sodium hydroxide, and weak acid, ethanoic. When the alkali is strong, the endpoint will take the strong one side. So it has to be strong alkali and a weak acid. Which one is strong alkali and weak acid? Not the A. B is correct. Yes, strong alkali and weak acid. Got it? If anyone needs any further explanation, let me know. Solution of sodium hydroxide of concentration 0.008 mole per decimeter cube has a pH. You have to calculate and see. pH plus pOH minus log to the base 10, 0.008. And pH plus pOH equals 14. So minus log, that is minus log 0.008 is 2. So 14 minus 2. Sorry, 14 minus 2 is 12. So it's between 11 to 13, right? 12 is between 11 to 13. Clear? You can also do this using Kw expression. Kw equals H plus times OH minus. That's also possible. A student carries out an experiment to determine the equilibrium constant for the reaction to form ethyl ethanoate from ethanol and ethanoic acid. Different amounts of each substance were added to the conical flask, each containing 2 centimeter cube of 1M hydrochloric. Why this is added? Why hydrochloric is added here? Because this is, you can see, this is a esterification reaction, and esterification reaction requires a catalyst, right? It requires a catalyst because it's a catalyzed reaction. That's the reason. Usually we use sulfuric acid as a catalyst, but here hydrochloric is given. So conical flask 1 to 4, hydrochloric volume, and then voice is decreasing. Is it for everyone? Let me know. Hydrochloric water is given, ethanoic is given, the ester is given, and the ethanol. The hydrochloric is same. So you can notice the first one, only the ester is there. Volume added is ester. That is ester hydrolysis. There's no reactants. Second, reactants are equally added, no products. Third, okay, the compositions are given. Anyway, the flasks were then stoppered and left for a week to reach equilibrium. Each mixture was then titrated with 1 mole per decimeter cube sodium hydroxide. Now, 1 mole per decimeter cube sodium hydroxide, when you titrate, first of all, HCl is a catalyst, so that will neutralize the catalyst first. After neutralizing the catalyst, we have to check whether, yes, whether there will be, if there's excess sodium hydroxide, the excess sodium hydroxide will react with the remaining carboxylic acid. So initial sodium hydroxide, which you add, will neutralize the all of the acid which is there, HCl, the catalyst. And the excess sodium hydroxide is what is used to neutralize the carboxylic. It doesn't react with alcohols because alcohols are not acidic. Neither it will react with the ester unless you heat. In which flask was the equilibrium approach from right-hand side of the equation? Equilibrium approach from right side of the equation. Right-hand side. That means this side. That means we need to have more of this. More of the ester. More of the ester. That means equilibrium started from the product. No reactants. Conical flask 1. Conical flask 4. No. That means you added the product. Product will break down, not the reactant. So 1 and 4. Answer is C. Which of these statements explain why it is possible to titrate the reaction mixture directly to find equilibrium concentrations? Yeah, because usually we have to quench the reaction, right? Because especially acid-alkali reactions or any other reaction is very fast. You have to quench the reaction first, and then only you have to take it out. And because reactions are very fast, you have to quench. You can't titrate because it's too fast. You can't. By the time you start the first titration, the whole reaction is over. At least you need to have about 3 or 4 readings, right? 3 or 4 different titer values. So why this particular reaction is can be titrated directly? Let's see. Maybe it's slow. We'll see. Equilibrium reaction is slow. This is a possible answer, but I cannot say that is the answer because I need to verify all the other answers. Because MCQs, you might have 2 answers. Out of that, you should mark the best answer, the best answer. Sodium hydroxide quickly hydrolyzes the ester. No, that doesn't happen at all. Because saponification reaction, ester hydrolysis, you have to warm. If you don't warm, it will hydrolyze extremely slowly, slow process, not quickly. This is wrong. Quick hydrolysis is achieved by heating. All the reactant concentrations remain constant during titration. How come that be? How come that be? You can't. All the reactant concentrations cannot remain constant, right? Because your reactant will react with because during the equilibrium it's reacting, and also the alkali will react with the acid, right? That is wrong. And buffer solutions form in the reaction. Buffer solution forms in the reaction. That's correct. When you add sodium hydroxide, you get sodium salt of carboxylic acid. That's right. And there will be unreacted acid. That's a buffer solution. That's correct. That's correct. 2 correct answers. What's the question? Which of these statements explain why it is possible to titrate the reaction? Oh, right. So as there are 2 correct answers, but as to the question, it says why is possible to find the equilibrium concentration directly. What is meant by directly? Without quenching. We don't quench the reaction. Directly, without you quench, directly you can find, because reaction is extremely slow. When the reaction is extremely slow, then you can do the titration. If the reaction is fast, what happens? Then you have to quench the reaction. The best way to quench this reaction is to remove the acid. Remove the acid by neutralizing the acid. Then when there is no acid, there won't be any reaction. So therefore, that will quench. the reaction. Right? I hope that's clear. Is that clear now? Okay. A statement, equilibrium reaction is because it's very slow, we can directly find the concentrations. If the reaction is fast, you can't find the concentrations, right? Because you have to quench the reaction. Because if the reaction is fast, if, for example, the reaction is completed in 1 minute, you can pipette out only one sample and do only one titration, right? But if the reaction is taking place in 10 minutes, you have chance of doing at least 3 or 4 titrations within that 10 minutes, right? So if the reaction is very slow, directly you can start the titration without quenching the reactants. So sodium hydroxide quickly hydrolyzes the ester? Nay, never. Alkali can hydrolyze the ester, no doubt, but hydrolysis requires adding alkali or acid. Now here is acid, here it's alkali. So alkali hydrolysis, the condition for alkali hydrolysis to happen is that there should be heat. So there is no heat means the hydrolysis will be very slow. So the answer will be correct if they say without quickly, slowly hydrolysis. It says quickly, right? A reactant Q is converted into 2 products. Which of these graphs show that this reaction is first order with respect to Q? This is equal concentration decreasing with time. Concentration decreasing with time. That means the gradient remains constant, right? Because the gradient of concentration time graphs gives the rate, right? Gradient of concentration time graph gives the rate. So rate is constant as the concentration of Q decrease. So this is example for a 0th order reaction. Zeroth order reaction. Second one, this is rate is constant with increase in concentration of Q. This is also 0th order. Rate remains constant with. This is the same graph. Gradient of the graph 1 is the B. Graph 1 is graph 2. Yeah. Rate increases as the concentration increase. This is first order. This is, say, rate is concentration is X. Rate is Y. Concentration X. Rate also doubled. That is first order. This is no reaction. With time, nothing happens to concentration. So graph 3. The question is about the kinetics of the reaction between nitrogen monoxide and oxygen. The rate equation for the reaction is rate equals this. Which statement is not correct? The reaction is third order overall. That is correct. 2 plus 1 is 3. At the partial order, at the overall order. So that's correct. But the question is, what is not correct? The units of the rate of the reaction. That's correct. Rate is concentration over time, which is moles per decimeter cube per second is the unit of rate. Rate of the reaction increases when the pressure is increased. That's right. Any reaction, when the pressure and concentration increases, the rate increases because frequency of the collisions increase. When the concentration of nitrogen monoxide doubles and the concentration of oxygen quadruples, the rate increases by factor 8. Let's say I take the nitrogen as X. Oxygen has also X, so it's X cube, right? I take the NO as X. Nitrogen oxygen as X. Now what? Nitrogen monoxide double, so I can make it 2X squared, and oxygen quadruples, 4X. You get how much? 8X cube. Sorry, 16X cubes. X cube. 2 times 2 is 4. 16X cube. So the rate is increased by 16 times. Not factor 8. Clear? Units of constant. What will be the units? Cube. Yeah. What will be the unit here? This is moles per decimeter cube per second is rate. This is moles per decimeter cube. So you can cancel one of it. You can say moles squared dm 6 per second. The answer like that, yeah. D. An experiment was carried out using 1.10 10 power minus 2 mole per decimeter cube oxygen and some nitrogen monoxide. The numerical value of the initial rate and rate constant are given. Was the initial concentration in moles? What was initial concentration in moles per decimeter cube of nitrogen monoxide using this experiment? How can you do this? Just substitute. Rate is known because rate equals rate constant times NO squared over 2. So rate is what? 3.20 10 to the power minus 3. What is K? 1.70 10 to the power 3. Nitrogen monoxide, and find the initial concentration. Oxygen, we take this nitrogen monoxide as X squared. Oxygen is 1.10. And can you solve this and get me the answer, please? Find the X value, that's all. Who got the answer? Answer, please. I'm sorry, I think my recording was paused. I hope the last bit was recorded. Let me just repeat it, because for those many are absent today, so they should understand. I think we were discussing about the. Let me just summarize what we discussed so far, because sorry, the recording was paused. So this is the peaks. This will split into. This is triplet, quadruplet, and this is singlet. So in this molecule, you can see these hydrogens will split into. This will split into a singlet. This is singlet because adjacent no carbon hydrogens in the adjacent carbon. This will split into a quadruplet. Adjacent has 3. This is split into a doublet. Adjacent, sorry, triplet. Adjacent has 2. So 3 is over here, which is Z. This is Z, and you have W here. This is W, and 1 and there are 2 single peaks, and one is more downfield. That is X. That is this one. This is X because attached to 2 electron withdrawing groups, and this is Y, attached to Y electron withdrawing groups. So that's that answer. And then splitting patterns of 4.2 and 1.3 I already explained. Splitting patterns at 4.3, splitting 4 adjacent, there are 3 hydrogens. Adjacent carbon has 3 hydrogens. And peak at 1.2 splits into 3. The adjacent, there are 2 hydrogens. And then C13NMR of the isomer of this, which contains the ketone functional group and the carboxylic acid, should be this, because this produces 1, 2, 3, 4 peaks overall in the C13NMR spectrum, right? So that is that answer. Just quickly going through what we discussed because the recording was paused. And as for the diagram of this compound, which is 0.45 is the RF value. 0.45 means slightly less than half distance. Here exactly half. The half means from the pencil line to the solvent front. You should mark the pencil line, you should mark the solvent front. Slightly less than the half. You can even measure the distance and take 0.45%, 45% of distance, right? So such is why RF value for ethyl 3-oxobutanoate is significantly lower than 0.45 if hexane is used as a solvent. Now this compound has a polar as well as non-polar groups, right? The polar groups are these, non-polar groups. So polar groups will dissolve in the polar solvent ethoxyethane, and non-polar groups will dissolve only in the non-polar solvent hexane. So non-polar hexane with a non-polar group, the attraction is dispersion forces, which are weak forces. But the polar with polar groups are strong forces, which is permanent dipole. So as dispersion force is weak, it travels less distance, right? Because it forms only London dispersion forces with hexane. So the interactions are a bit weak. The London dispersion force interactions are weak. That's the reason it travels less distance. So take a short brain break and continue the rest after the break. This is question 17. This is a long question. Let's see how many marks given. This is a very important question. 6 marks, 2 pages. Before we answer this type of question, we have to structure the question separately, and we need to write the answer. Compare and contrast the reactions of propanol and propanol with 1 oxidizing agent and 1 reducing agent and 2,4-dinitrophenylhydrazine. Now we know propanol and propanone with oxidizing agent, like such as potassium permanganate, potassium dichromate, and we can even use Fairlings or Benedicts. There'll be oxidation for the aldehyde, not for the ketone, right? And as for the reducing agent, lithium aluminium hydride or sodium borohydrate can be used. It can be reduced for the corresponding alcohol, secondary alcohol, and propanone gives secondary alcohol, propanol gives a primary alcohol. 2,4-DMP gives the precipitate at hydrazone. Your answer should include any relevant observations. Of course, there are so many observations. Each reaction has observation except for the reduction. For the reactions you discuss and the equations for any reactions classified as oxidation, use O for the oxygen from the oxidizing agent. That means you all need to write and balance. Why they say this? Use O. If not, if you're using dichromate, we can't balance it, right? You can't write dichromate and chromium in the equation. So simply we put O. That makes things easy, right? So how do you, why so much of space, and why, let's see, why they have given marks, how they are given the marks, 6 marks. I'm sure they would have given marks for the equations and observations and the explanation why some undergo oxidation and why it can be reduced as well, right? So observations carry marks, and the product, the main reaction, writing the main reactions carry marks, and the what you use as oxidizing agent carries marks. You can use Fehling's, Benedict's, or potassium dichromate. Clear? The thing is, now the question arises why there's so much of space given, right? There is marks given for the linking the points together, right? There should be link between one point to the other, right? So we'll see how we can write the answer with the proper link. Because let me just I'd like to see the marking scheme. Just give me a minute. I want to see exactly how they are given marks for this, because my worry is why so much of space given, because one page is more than enough, but the space is given, I know it's explanation and the linkage, linking one point to the other. So you have to reason it, link one point to the other, right? Logically structure the answer. Just answer itself will not get the 6 marks. So if you just write the answer, you might only get 4 marks without proper explanation. So that is how they have given for linking one point to the other, they are given 1 mark, right? So there is it's a bit complicated marking scheme as well. It's still difficult to, yeah. They're given some marks 6, 5 to 4, 3 to 2. Guidance on how marking scheme should be applied. The mark for the indicative content should be added to the mark for lines of reasonings, for example, or possible with 4 indicative marking points with the partially structured with some linkages, lines, reasonings goes 4 marks, 3 marks for inductive content, and 1 mark for the partial structure and some linkages, lines of reasoning. If there's no linkages between the points, then the same inductive marking points would be yield overall. It's actually from the new syllabus. It was never there in the old syllabus. This is the first paper with this type of question. So this type of question, you get 1 question with 5 or 6 marks with this type of reasoning and writing. This is from the new syllabus. Okay, so let's write the answer. Right. So here, if you read the question again carefully, compare and contrast. Now, the contrast meaning here to show the difference between the two, right? We have to clearly show the difference between the two, right? Okay, let's write the answer. If you've written the answer, please check. When propanol and propanone, so you must always compare the difference, right? Compare and contrast. When propanol and propanone is reacted with oxidizing agent, such as acidified potassium dichromate, acidified with concentrated sulfuric acid. When heated under reflux, the propanal will undergo oxidation. Change in the orange color of potassium dichromate. Change in the orange color of potassium dichromate. Change in the orange color of potassium dichromate. From orange to green. From orange to green. This is due to the formation of propanoic acid. And the green color is due to Cr3 plus ion. The ketone will not be oxidized. That's the first point, right? Next point, you can write both propanone and propanal can be reduced by reducing agents such as sodium borohydrate or lithium aluminium hydride. Sodium borohydrate is also referred to as sodium borohydrate is also known as sodium tetrahydroborate. That's another alternative name. Or you can say or lithium aluminium hydride, which is also known as lithium tetrahydroaluminate. Okay, so then you can write the reaction. Propanal. You can either use lithium aluminium hydride or sodium borohydrate. You get the corresponding alcohol. This is primary alcohol. You can write as primary alcohol, and propanone. Secondary alcohol. There's a delay in the pen. Let me check. Okay. I'll just log out and log in for a minute because there is some delay in my G pen. I cannot write it clearly. There's a delay after I write. After some time, it appears on the board. So just hold on. Till then, you can copy these two. This is secondary alcohol. Right? Just copy this.
You are currently the only person in this conference.
It's okay now. Done. That's all about the oxidation, the reduction part. At last, we need to talk about the reaction with 2,4-dinitrophenyl hydrazine. Then you can write that both propanal and propanone will react with 2,4-DNPH. Will react with 2,4-DNPH. From orange precipitate. So you can write the reaction for that. So this is OH goes with, the O goes with the water. Water molecule is lost, and then you got the precipitate. You get the precipitate, which is hydrazone. Right? Same thing you can draw for the aldehyde. That is just you substitute this CH3 with H. Right? Please draw the aldehyde also. As for the other reaction, you just substitute the same thing. What you can do is you can erase this, just replace this CH3 group. You can substitute this with the hydrogen here. Right, that's for the aldehyde. This is a double bond here. There's a double bond, remember. C double bond forms a double bond with the. This is NN single bond, and there's a H here. There's a H here. Okay, so that's that question. The next one, question 18. The weight constant for the reaction to convert cyclopropane to propene was determined at 5 different temperatures. Complete the table, plot a graph of L and K against 1 upon T. So how to complete the table is 1 upon this value. You can do that, right? And Ln K, you have the K value, take the Ln value, and you can plot the graph. So when you plot the graph, when you're taking the values in the graph, make sure at least 2/3 of the graph paper is used, and then plot the best fit line, right? 2/3 of the graph paper has to be. I'm not going to do that just to save time. And what you do is you, in order to find the activation energy, you calculate the gradient. Now, when you're calculating the gradient, right, when you say, for example, your graph is like this, right, when you want to find the gradient, you take 2 random points and find the tan theta value, the y distance over x distance, right? Y distance over x distance, because the reason is that don't ever use values from the table to calculate the gradient. Then if you use values from the table, you're going to lose 1. Please don't use these values for the gradient. You're going to lose 1 mark. You're going to lose 1 mark, because if you use the values from the gradient, then why do you plot the graph in the first place? Graph is plotted to minimize the experimental errors. So this is your x-axis. This is your y. This is your intercept, C. And this is your m. The gradient, once you find, which is equal to minus EA over R. R is known, 8.314. I think the R value is given in the data booklet as well. 8.314 gradient. You cross multiply with a negative gradient. So negative, negative, you get the answer as positive. Can someone get me the answer, please? You get the answer in kilojoules or mole. You can get the answer in kilojoules or mole. You should get an answer between 34,200 and 31,200. So in that range, if you're getting an answer, that's perfect. 34,200 to 31,200. So the only this answer within this range is accepted, right? So I'm going to skip that part because it's just plotting the graph and calculating the gradient. The activation energy for many reactions is around plus 50. Given this information, comment on your value for EA. Now we are getting a huge value, right? Huge value, right? Sorry, this is 31,000. That is a gradient value. I'm sorry, I should mention the gradient value. Activation energy will be somewhere plus 272 because this is a gradient value I mentioned before. 34,000. That value is the gradient value, right? It is a gradient. So the activation energy should be somewhere close to 270 odd, right? So just keep that, keep a note on that. So now compared to 50, the 200 is about 5 times more. 272 is about 5 times more. So the reason is, let's see, what is this reaction? Maybe the bond activation energy is very high because the bonds are very strong. Maybe that can be the reason. You can say a lot of energy is required to break these bonds, strong carbon-carbon bonds. Right? You can say a lot of energy is required to break the strong carbon-carbon bond. A lot of energy is required to break the strong carbon-carbon bond. So a lot of energy is required to break the strong carbon-carbon bond. A lot of energy is one mark. That's why the activation energy is very high. That's the reason why reaction is very slow. And this is due to the strong carbon-carbon bond. Explain the trend in the value of the rate constant as the temperature increases. Now, as the temperature increases, what happens? Rate constant increase. The reason is that when the temperature increases, there'll be more molecules with the energy higher than the activation energy. So that results in increased frequency of collisions. So that gives a higher reaction rate. So when the rate of the reaction increase, what happens simultaneously, rate constant also increase. So whatever happens to rate constant. If the rate increases, rate constant also will increase. Right? They are proportional, directly proportional. What rate decreases, rate constant decrease. Right? So you can write first, as the temperature increases, there will be more molecules with energy greater than the activation energy. This results in increased frequency of collisions. Which give rise to high reaction rate. As the rate of reaction increases, the rate constant will increase. So that's the 3-mark question. That's the end of that one. The next question. Silicon tetrachloride is used in the manufacture of optical fibers. It can be made by the reaction of silicon carbide with hydrogen chloride using a catalyst of nickel 2 chloride. The entropy values are given. Calculate the total entropy change for this reaction. You have to first find the system entropy that you can do, right? Total the number of moles of entropy of the products minus total the number of moles of entropy of the reactants. Now, when you say the products, you have two products. You have to add these values: silicon tetrachloride value and methane value, and the reactants, silicon carbide value and 4 hydrogen. That means you have to multiply this by 4. So that can get the system. As for the surroundings, minus delta H over T. Delta H is already given, right? We have to multiply that by 1000 to convert the kilojoules into joules. And then you can work out the delta H total. Delta H system plus delta H. So I'm not going to do this question because we had done enough of questions using entropy. So we can easily do this, right? So I'm going to skip and spend more time on the difficult ones, skip the easy ones. I hope all of you can do this. If you had done, let me know the answer. I think it's endothermic, yeah, I mean overall positive feasible reaction. Don't forget the reactants, HCl to multiply by 4, right? That is important here. So that can be done. In industry, the reaction is carried out at 700 degrees Celsius by considering the entropy and other relevant factors justify the use of this temperature. Now, at 700 degrees Celsius, now what happens here? This is exothermic reaction, so delta H. This reaction is exothermic, right? See, the reaction is exothermic. So the delta S surrounding is minus delta H over T. When the temperature increase, minus means plus. The overall positive value of the surrounding entropy decreases. When the temperature increase, minus is plus. So positive value of the surrounding will decrease. When the positive value of the surrounding decreases, it becomes less feasible. Overall, entropy becomes less feasible, right? So you have to mention that when the temperature increases, you can mention the equation delta H surrounding equals minus delta H over T because it's a thermic reaction. So when the temperature increases, the positive value of the entropy of surrounding decreases. Positive value of entropy of surrounding decreases. As a result, the total entropy will decrease. The reaction becomes less feasible. Okay, you can do that one. That's done. Next one. Use the answer to A1 to calculate the equilibrium constant for the reaction at 298 Kelvin. What's the equation? Delta H total equals R ln K. Delta H total we found in the first equation. R is 8.314, so you can find the K. Right? You can find the K. That can be done, right? With the use of shift log value, inverse log value. That can be done, so that question is fine. Complete the bond-Haber cycle, adding letters and boxes for energy changes. This is what reaction? Calcium. Okay, now this is calcium iodide. This is enthalpy of formation. A, this is atomization of calcium. It's already given. D is you're atomizing iodine. That is D. Then usually what we complete one and then start the other one, but here it's not like that. You have to ionize. Now we first atomize both and then ionize both. So here calcium, this is the, have they given the first and second separate ionizations? Yes, first and second. So this is, first one is B, second is C. So this is the first ionization of calcium. This is second ionization of calcium. Right? And then electron affinity. Only one electron affinity. The first electron affinity is always exothermic, right? That is iodine E. This is E. So calcium 2 plus 2I minus. And this is a lattice energy, right? Lattice energy, what is that? F. So you have to write the arrows properly. This is F. So you have this arrow going up. This goes up. And this comes down again because first electron affinity is exothermic, others all endothermic. And then this is the product. Please check your answers. Usually you have to calculate the value for enthalpy change of formation of calcium iodide. What you need to do is you have to add all these arrows. See, all these arrows are facing the same direction, head to tail, 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 head to head, tail to tail. So add all these values and make it equal to the formation, right? So simply add everything. And here, don't forget, you have to multiply this by 2. Don't forget that. Which one? Multiply the electron affinity by 2. Right? And this is already multiplied by 2 and given, so do I have to multiply those values by 2. So basically add all where you need to multiply because all these arrows are in the same formation. You get the answer for that. Right? I think you can do that. So just addition. So since I need to complete the paper, I'm just going to do only the difficult ones, right? The value of the lattice energy of calcium iodide is determined experimentally using Born-Haber cycle differs significantly from the theoretical calculated value. That's correct because what you get from the Born-Haber cycle is the experimental lattice energy of experimental true lattice energy of a compound, and what you find from the Born-Landy equation is a theoretical one. Theoretical one is very close to the experimental value if it is more ionic substance. If the lattice is more ionic, that means theoretical and experimental values go next to each other, very close, because the theoretical one is calculated using the equation. For that, you need to calculate the R plus R minus value. The R plus and R minus value will be the true values when it has a greater ionic character. But if it has a greater covalent character, what happens? Electron density map get distorted, right? Because covalent character means the electron density map towards the cation, electrons will be more pulled like this. So therefore, you get a false value for R minus. That doesn't happen if the polarization is less. then you get that is slightly there, but it's almost very close to the correct value, R plus, R minus. So if you have a cation with a greater polarizing power and anion with a greater polarizability, that means it favors covalent character, which means it pulls the electron cloud from the anion towards the cation. So when that happens, we get a false value for R minus. So therefore there will be a big difference in the theoretical and the experimental lattice energy. So calcium fluoride and calcium iodide. Calcium fluoride is more ionic. Therefore, the distortion of the anion is less. But the calcium iodide is more covalent. And iodide is more polarizing. We will talk about the polarizability of the fluoride and the iodide, not the polarizing power. We don't discuss about polarizing power here because the cation is same. So iodide has a greater polarizability. So therefore, it has a greater R minus. When the R minus is greater, you get a false value lattice energy. That means a very low value than the expected value. I can write the answer for that. Fluorine is less polarizable. Fluorine is less polarizable compared to iodine. As a result, calcium ion, the calcium ion iodide ion is polar. What did I say? Therefore, calcium ion polarizes the iodide ion to a greater degree than the fluoride ion. Calcium ion polarizes the iodide ion to a greater degree than the fluoride ion. Therefore, calcium iodide has a greater degree of covalent character. And calcium fluoride has a greater degree of ionic character. Calcium fluoride greater degree of ionic character, and calcium iodide greater degree of covalent character. When the covalent character increase, difference between theoretical and experimental values will increase. Electron affinity of iodine is given. Explain how the electron affinity of chlorine differs from that of iodine. Now, chlorine is a small ion. It attracts electrons easily than iodine. Right? So, electron affinity of chlorine is more exothermic. Small ion, great attraction. Right? Electron affinity of chlorine is more exothermic than iodine. As chlorine is a smaller atom, therefore has a greater charge or greater attraction, therefore has a greater attraction compared to iodine. Section B is done. I think we have how many more questions? Section C, 3 questions. 4, 5. Okay, we just try to see what we can do. Easy ones I'm going to skip. This question is about ethanoic acid and some of its compounds. 3 students A, B, and C carried out investigation to determine the amount of isoamyl acetate and ester of ethanoic acid in banana food flavoring. They hydrolyzed the ester with excess sodium hydroxide solution, sodium salt of carboxylic, and the alcohol. The amount of sodium hydroxide remaining was determined by titrating the reaction mixture with hydrochloric acid. The systematic name for isoamyl acetate. Systematic name. Now we have to first name the alcohol part. You can see the alcohol is this. This is 1, 2, third carbon has 2 methyl groups, right? So this is 1, 2, 3, third carbon has. So this is 3 methyl. I'm going to name the alcohol first. 1, 2, 3, 3 methyl but for butanol. That's the alcohol. What is the carboxylic? Ethanol, ethanoic acid. So ethanoic acid with 3 methyl butanol, you get the ester. You name the alcohol first. 3 methyl butyl ethanoate. Name the alcohol first. 3 methyl butyl ethanoate. Then the carboxylic group with the weight. (6.06 in 10 power minus 3 moles of sodium hydroxide reacted with the ester, present in 1.07 grams of the flavoring. Calculate the percentage by mass of the ester in the food flavoring. That means this is the moles of the ester as well. Moles of sodium hydroxide, the moles of the ester, right? So moles of the ester we can find first, is already given. Moles of ester is 6.06 10 to the power minus 3. That's the moles, and then have they given the molar mass? Where to find the molar mass? What's the molar mass of the ester? Then we can find the mass. What's the molar mass? So 1, 2, 3, 4, 5, 6, 7, 12 times 7. 5, 6, 7, 8, 130, right? Molar mass of the ester is 130. So mass will be moles into molar mass, right? What is the answer get then? Point 0.7878. Point 7878, yeah. That's the mass. So the actual mass is this. This is the expected mass, 1.07. So the 1.07 is the mass of the ester. Actually, you have the substance, this amount. You can find the percentage. It's 73.6. So this amount of ester, 1.07, actually has a flavor 0.7878 grams, so 100%. Get the percentage by mass of the ester in the food flavoring. So then use 25 cm cube of sodium hydroxide solution with the concentration of 0.9 mole per decimeter cube for the hydrolysis. Calculate the pH of the reaction mixture when hydrolysis is complete. Assume the total volume is 25. Okay, so let's find the number of moles of sodium hydroxide. 1000 contains 0.98. 25 contains how much? Right? This is 0.0. 245 moles. Correct? Now look at this. Now this is total volume is 25. Okay. So this is the number of moles of the ester, which is sodium hydroxide, which was used, right? So we had to know initially how much sodium hydroxide is there. See, this amount of sodium hydroxide is reacted. So this is the amount of sodium hydroxide which is used. That is the amount which is reacted. So to find the sodium hydroxide, which remains 0.04245 minus the reacted amount, 6.06 10 to the power minus 3, right? So we get the amount of sodium hydroxide which remains. What is the answer there? 0.0184 moles of sodium hydroxide remains. So that moles of sodium hydroxide is in how much of volume? Find the concentration now. Total volume is 25. So let's find the concentration of sodium hydroxide. This moles present in 25, number of moles in 1000. What's the concentration? Point 0.7376 moles per decimeter cube. Now what you can do is you can use the pH, pOH, or you can, how to do this step. From here onwards, Kw equals H plus time OH minus. We know the OH minus here. Kw is known. You can find H plus. Once you find H plus, you can find the pH. So that can be done, right? Two indicators, methyl orange and phenolphthalein, are available for this titration. What is this titration now? Strong acid titrating with what? Sorry, strong base titrating with what? Titrating with what? Hydrochloric acid. Right? Strong acid, strong base. Strong acid, strong base. Many can be used. Many can be used. Methyl orange can be used. Vertical, it falls in the vertical range. Phenolphthalein can be used. And actually, student C is correct. Either indicator can be used because the vertical inflection, strong acid, strong base, falls within the pKa value of these two indicators, right? Right. So student C is correct. Student C is correct. As a vertical inflection of the strong acid, strong base titration falls within the pKin value. Falls within the pKin value of both the indicators. Describe how the sodium ethanoate in the final reaction mixture could be converted into ethanoic. Can you just add acid? Can add hydrochloric acid. We can convert the sodium salt into the corresponding carboxylic acid, because sodium salt of a weak acid is alkali. Sodium salt of a weak acid is alkali. So you need to add acid to neutralize that, right? So just add HCl. We have the 2 questions, right? Yeah, let's just quickly go through that. Ethanoic acid can be used to form buffer solutions. pH of the buffer solution formed in 50 cm of ethanoic acid with concentration 0.15 mixed with 30 of sodium hydroxide. This is a good question. If you remember, I had done similar questions in the tute, right? The study pack, ethanoic acid with sodium hydroxide. You get sodium ethanoate plus water. Ethanoic acid is 50 cm cube, 0.15 m, 30 cm cube of sodium hydroxide, 0.142. Let's find the moles first of both. Can those who have done the calculation please get me the answer so I can do it faster? Get me the moles of ethanoic acid first. Sodium hydroxide moles. What's ethanoic acid moles? 0.0075. Sodium hydroxide 0.00426 moles. Now 1:1 ratio, so therefore all of the sodium hydroxide is going to react, right? And that will be the amount of salt which is formed, just 0.00426 because 1:1 ratio. And the remaining acid concentration we had to find, remaining acid moles. So remaining moles of the ethanoic acid, because buffer is acid concentration and the salt concentration we need to work out, right? Remaining moles of ethanoic acid is 0.0075 is initial, out of which reacts only 0.00426 because 1:1, so that's in excess, only 1:1. 426. So answer here is what? 0.00324 moles. And what is the concentration now? This moles available in how much of volume? 30 plus 50 is 80. So now you can find the concentration of the carboxylic acid. This much of moles, percent in 80, number of moles in 1000. What's the answer? Likewise, you can find the concentration of the salt. 0.00426 moles percent in 80. Right? Number of moles in 1000. So once you got this acid concentration and the salt concentration, that's then done. So Ka, can use the H plus equation to find the pH for buffer. Ka times acid over salt. Acid concentration we just found, salt we found. Ka of the ethanoic acid is given. Have they given? Yes, ethanoic Ka is given. You can find H plus. Then you can work out the pH. We had done enough of questions of this nature. Any questions here? So you have to work out the concentration of the acid remaining, right, and the concentration of the salt, both. Any questions here? Any question there? Right, so the last one. Small amounts of sodium hydroxide and hydrochloric acid are added to the separate samples of buffer solution B1. Explain why these samples resist changes in pH. So this is this acid I represent as HA. You can the acid is ethanoic acid. Ethanoic, right? Yes. I can write the formula of the acid because it's a simple acid, ethanoic acid. Let me write the two. I think I had given these type of questions we had done. Right? It partially ionizes to give ethanoate ions and H plus. First, we write the equations, and then you have sodium ethanoate completely ionizes. Write the two equations first. So then, what you have to explain what happens when you add H plus. When you add H plus ions, it combines with the ethanoate ion, most of which comes from the salt, to form the unionized acid. So after writing these two equations, then write when acid or H plus is added, it combines with ethanoate ions, most of which comes from the salt, to form the unionized acid. Likewise, in alkali, or the OH minus is added. Likewise, you can say the alkali or the OH minus is added. It combines with the H plus ions. It combines with H plus ions to form water. So as a result, the acid to salt concentration ratio can say the acid to salt concentration ratio or salt acid concentration ratio remains almost constant as this mixture contains a large reservoir of ethanoic acid and ethanoate ion. Ethanoic acid and ethanoate ion. Right, so that last point is important. So with that, we conclude. Thanks for your patience. I took a little extra time. I just want to complete the paper. And the next Saturday, the next Sunday class, we'll discuss the latest paper, 2020 October, which I uploaded in the website, so you can download. So we'll discuss that paper, the next lesson. So with that, we'll conclude for today.